Hey everyone, my name is Soumya Upadhyaya and I'm part of the product marketing team here at GitLab. And today we're going to talk about developing for the cloud native world with GitLab. Let me share my screen first. Okay, so many organizations these days claim transformation is top priority to make the workforce a lot more agile, remote, collaborative, especially in the last 2 years. But it's table stakes now. But this transformation has been difficult to achieve for a lot of organizations, as per McKinsey. And it is not because of the lack of intent, right? They've been doing the right things. They've been hiring the right people, training, buying the right tools, working with partners, and so on. But it's really not adding up to the returns that they expected. And in the process, they have spent thousands of dollars, thousands of hours, and millions of dollars in trying to achieve this transformation. And why has this been so difficult, right? So, in the rush to transform, organizations are modernizing their infrastructure. Obviously, they're moving to cloud, they're moving to cloud containers and cloud native technologies. They're modernizing their applications as well. They're moving from monolithic architectures to microservice architectures. We'll talk about that in a little bit. They're modernizing the tool sets. They're bringing in tools, various different tools to cater to this new form of working, to make them a lot more agile, to make them collaborate a lot more. And of course, they're modernizing their processes as well. They're moving from a waterfall model to an agile based development model. By doing this, they hope their teams can work in parallel, they can work independently, and they can move faster, which is all good. But all this has just meant that there is a lot more to manage. So, as we talk about the shift, right, the landscape in a cloud native world gets a little bit more complicated. The needs from cloud native development are also very different. So, in order to achieve flexibility and scale, developers are using lightweight containers. The deployment packages are getting smaller as opposed to previously it was a monolithic application. What this means is that there are now multiple entry and exit points for the application itself, as opposed to a traditional application having just one entry and one exit point. All of these interfaces, the multiple entries and exit points, need to be managed as well, ensuring firewall and security restrictions are in place. Developers are also using a variety of languages and frameworks to achieve this flexibility. The applications are abstracted from the server and the operating system dependencies, which means that they have now the flexibility to choose any operating system, any deployment target, meaning ops teams need to be able to support this entire range of environments as well. The goal is to have the processes automated, which means that developers spend more time on coding and creating value rather than on the processes, therefore accelerating their pace of development. Now, the flexibility developers have achieved over the years with their choices of languages and technologies means that they're able to deploy to a wide variety of constantly expanding platforms. They can choose, let's say, Azure for their development environment, GCP for their staging environment, AWS for their production environments. Moving from one platform to another is easier and faster because of the abstraction that can be achieved with cloud native and containerized technologies. And the future is all about scale and choice, right? Scaling out the types of targets, scaling out by shared numbers, scaling out by topologies, and so on. The rest of the teams, like the infrastructure, operations, security teams, have to keep up with this change that is ensuing the development environments. So, to keep up, as the modernization of infrastructure, application, and processes ensued, teams brought in different tools to manage very specific problems that they may have. You have a code repository problem, bring in a central repository. You have a code review problem, bring in a tool to solve that. You have a security problem, you bring in a tool to solve that security problem, and so on. Just imagine let's take security as an example, right? Just imagine working with a different tool for static application testing, dynamic application testing, container scanning, network security, license compliance, and so on. Just listing this, that's 5 different tools just to manage your security posture. There may be many other tools for different parts of your DevOps lifecycle. This may as well be the case in your organization. So as teams adopt Agile and DevOps, the toolchain complexity and the digital duct tape has continued to rise. And with that, the number of tasks they had to perform and integrations they have to manage have increased significantly as well. Cloud native typically requires a different way of doing things, right? It requires a lot more automation than before. Let's start by talking about where organizations currently are. We conducted a global DevSecOps survey, which had over 4,000 users. We also looked at the 2021 State of DevOps survey. The results were consistent across these surveys, right? Organizations still have a long way to go when trying to achieve automated software delivery. Only 25% of organizations have achieved test automation. It requires a basic behavioral change to move developers and QA teams from storing the test code in their system to actually automating it as a part of the process. Not enough code review is done because code review is still a lot manual and still ad hoc. In fact, to make code review better, GitLab acquired a company, Unreview, to make code reviews better by using machine learning to identify who the best reviewer can be for a piece of code. Now, operations is still manual as well, right? Only 19% of ops teams have achieved full automation. Although cloud is now table stakes, right? It's a given in most organizations. Only 25% of organizations are using cloud to their full potential. Many are only just using the basics of cloud, which include automated scaling of resources. Not to mention, collaboration is still a big challenge. 58% of teams have multiple handoffs between teams, which is highly inefficient. Of course, this lack of automation does not come without consequences, right? Manual processes means frequent rework, wasted cycles, and budget, and hence lower employee productivity as well. Such manual processes are almost impossible to manage in a cloud-native world. Lost business opportunities as the business has poor agility to execute and capture market share compared to their competitors. Poor developer experience. Now, skilled talent is hard to recruit. We all know that. Lack of automations results in high employee turnover and inability to retain the talent that you already have, which is a big challenge. And at the end of it, there's poor customer experience, right? Imagine a scenario where an organization is not able to restore the services fast enough. Not only does this cause business disruption, it also affects the organization's reputation and causes customer attrition. Let's try to quantify some of these things that we've spoken about, right? Taking quality assurance as an example. I think we're all familiar with this. Finding and fixing bugs and vulnerabilities earlier in the cycle is a lot cheaper than finding it and fixing it later in the cycle, right? For example, when a defect or vulnerability is found during coding, it is already 5x more expensive than finding it during requirements or design, right? If we let that slide, it becomes 10x more expensive when it is found during testing. It becomes 30x more expensive when it is found during production. So as we rethink automation, we have to think about how do we start detecting these problems a lot earlier. I think the problem statement is clear, right? We have to find defects and vulnerabilities earlier to make sure, one, that it is cheaper to fix. The second, that it requires less context switching for your developers to go back to the place where the problem occurred. And third, your management at the end of the day does not need to take a decision or a call on the day of the release, whether to release the product with a vulnerability or go back and fix it, therefore delaying the release and credibility and lost opportunities and so on. We've spoken about that. So if an organization does pursue automated software delivery, right, what does success look like? What can you aspire to achieve? The Accelerate State of DevOps report by Google gives some guidance and perspective on that, right? So organizations can move from a deploy every few days or few weeks or few months in some cases to deploying on demand. In most cases, multiple deploys in a particular day. Before automated software delivery, multiple code commits would be bundled together for a single release. With automation, organizations can take an hour from code commit to deploy based on the complexity of their pipelines. Without automated software delivery, on service downtime, organizations would attempt to debug in the live production environment till the problem is resolved. That means your downtime is longer. With automation, they can actually revert back to the previous stable release and then investigate what really went on, implying less than an hour to restore services. Since testing, including security tests, are now integrated as a part of the deployment process, organizations can aim for less than 15% change failure rate. That is the percentage of times a change causes a service degradation. So we've spoken about what the challenge has been and what we can aspire for with automated software delivery. How do we get started? All right. So based on our experience with thousands of customers, we have some guidance on this. Firstly, start where you are. It is rare that an organization will choose to rip and replace what they already have, right? Instead, they will bring along a new solution and then expand it as the maturity of use increases and the capabilities that the platform brings. For example, GitLab integrates with leading tools like Jira, GitHub, Terraform, Jenkins, which allows you to start with very specific use cases. As per a Forrester TEI study that we did, over time, organizations that did adopt GitLab were able to replace 3 tools per year with GitLab once they got comfortable with the tool. Next, you need a solution that is quick and easy to start, right? Not clunky and does not require a lot of maintenance. Most feedback for GitLab that we've received claims that it just works, right? It's extremely simple to start. Even a number of Gartner peer reviews state that. As you're planning for a new solution, you have to take a longer term view of where your organization will invest in. What cloud native, what multi cloud technologies are the areas that your organization is interested in pursuing. You also need a solution that will support these plans. Now, GitLab natively integrates with Kubernetes and also supports multiple clouds like AWS, GCP, and Azure. So you don't need to make the decision right now on your choice of cloud, but you can be rest assured that that will be supported when you do need to take a decision. Next, you need a solution that is consistent for both application and infrastructure teams, right? So that the collaboration across the teams can improve. You also need a solution that can support both your cloud environments as well as your traditional environments. So you don't need a different tool to manage both of them. Again, effective collaboration. So GitLab can support multi-cloud, multi-tier applications, cloud applications, and infrastructure with ease. We've spoken about developer experience in the past. So developer experience and productivity gains is a key for success for all organizations, right? There's no denying that. For this, you need to remove the irritants from the developer's workflow. Irritants like waiting time, irritants like integrating time, maintaining time, context switching time, and so on. With a single application that covers different parts of the DevOps ecosystem, GitLab removes that friction for developers so that they can operate at their peak performance. And lastly, customer experience is key, right? How easy is it to trace back to an issue in production and then roll it back to a stable release? How easy is it to troubleshoot and pinpoint the changes that resulted in the issues? This not only improves the stability and reliability of the application in production, but also ensures customer experience is at its peak. So how can we achieve this, right? There are a few basic capabilities that organizations can build on to achieve automated software delivery. for cloud native, right? So not all organizations need to achieve everything in one shot. It can be incremental and added in as their maturity improves. The first is continuous change management, right? So you need to move from storing things on the developer's desktop, or FTPing the code into production, to storing everything, to having everything in code, and that's the starting point for automation. You can track every change for your applications, infrastructure, policies, configurations, and so on, and ensure only approved changes are going into production. You can also include controls, right? Like approvals, reviews in an automated manner to bring structure to your software delivery process. The next step is continuous integration and verification. It is not just important to store your code, everything in code, but also incrementally test every single change, so that you can detect errors earlier. Like we discussed earlier, an issue detected in production is 100x more expensive in terms of time and cost to fix than it is to detect and fix it earlier in requirements or development cycle, right? So testing everything incrementally is key, so that changes are a lot more manageable. It's better to find and fix a handful of defects towards the end of the cycle rather than fix thousands of defects at the end of the cycle if everything is deferred. Now, it's not just important to automate only applications, right? It's also important to automate infrastructure provisioning and management. With cloud native and multi-clouds adoption, as the scale of the target environments have grown significantly, it's practically impossible to do infrastructure provisioning and deployment manually, right? That's where GitOps comes in. It helps not just to automate infrastructure configuration, but it can also detect any changes required in the target environment and deploy those changes automatically without too much manual intervention, if your organization is interested in that. Otherwise, you can set in approval rules in place so that the changes are only deployed once they are approved. And last is continuous delivery, right? With continuous integration and verification, every change is technically releasable, but we need to have controls in place. We need to be able to progressively deploy, gather feedback from the subset of users that you have deployed to before deploying the change to all users. If there is an issue, we should be able to revert back to the last working version at a minimum with a minimum downtime. These are the basic building blocks. You can start at one or more of these places and add on these capabilities as your maturity improves. So how does this all fit together, right? So we've spoken about what success looks like. We've spoken about what the critical capabilities are. Let's tie them all together, right? A typical workflow for a developer would look like this. As soon as the developer commits their code, the CI/CD pipeline runs with various builds and tests, including security tests. Now, the developer, before they move on to something else, should be able to visualize all defects and vulnerabilities of the code that they have changed, right? And determine whether it needs to be fixed now or later and raise an issue to fix it at some point. Now, in this case, a defect or vulnerability is fixed during the natural workflow of the developer, right? Therefore, it takes much lesser time for the developer to fix it, and also the cost is lower for an organization. Now, we are also including security as a part of this process. This is security by design, and part of the workflow makes security and compliance teams a lot more scalable. Because let's be honest, right? There will always be more developers than security and compliance folks in an organization. So we spoke about this briefly a bit earlier, where we said that cloud native development requires changes not just for your application development, but also the way cloud infrastructure is provisioned and managed, right? You cannot do things manually anymore. So notice how the pipeline for both application and infrastructure automation pretty much remains the same. This minimizes the learning effort and also helps different teams collaborate on the same platform. Both application code and say infrastructure code are on the same platform. We can also use something we call cross-project pipelines, which can ensure that the application pipeline triggers the infrastructure pipeline with all the necessary changes before deploying, right? Or the infrastructure pipeline triggers the application pipeline after the environment has been set up. You can set it up in any which way you want, but these cross-project pipelines also automate the collaboration aspect between these two teams. Now, GitLab helps you achieve all this and more, right? Working with hundreds of customers across various domains, we understand the pain of having many different tools to do different things. So we've created a better way to do it. We've created the one DevOps platform that is really a single application with one single user interface, one single data store, one single permission model, and security is embedded in the DevOps lifecycle. Remember, a frequent misconception is GitLab is just Git. It is not just Git. It is much beyond that, right? In a single application, you can do project planning, development, security, release management, operations, monitoring in a single application. So it helps various different teams in your organizations to collaborate with a single solution to manage the end-to-end development lifecycle, thereby helping you to deliver value a lot faster, increase visibility across these various different teams, increase quality, and increase security as well. So now your teams can focus on value generating, revenue generating tasks rather than thinking about how to manage various different tools or how to manage various different processes across these different teams. And GitLab, when we're talking about cloud native, right? So GitLab is not retrofitted for handling cloud native. It is optimized for cloud native with all the necessary capabilities that you see on the screen to make cloud native transformations a lot easier. It handles both your traditional environments and cloud native environments with the same level of ease. So you can manage both your environments from a single platform. And it's not just saying this, right? We share this vision of a single platform or one DevOps platform with various companies and organizations of various sizes across the world. The largest and most innovative organizations have already shifted to a platform approach, and they're using it to activate their transformation investments. Let's take a little bit of a deep dive into one such example before we close, right? So it's interesting to note that the world's largest hacker-powered security platform uses GitLab to secure their workflow and application, right? So as the team at HackerOne scaled from 10 engineers to 300 plus employees, the time it took waiting for the pipeline was prohibitive, right? This made people overly cautious about pushing code, which overall affected the pace of development, overall affected productivity, and the pace of releases. Excuse me. With GitLab, they were able to bring down the time of this pipeline from 60 minutes to 8 minutes with all the tests integrated, including security tests. So this improved developer productivity, improved developer experience. They didn't have to restrain themselves from pushing code because it takes 60 minutes. And hence they were able to deploy a lot faster as well. This was possible because of all of these pieces being integrated together as a part of the one DevOps platform. And with that, I will pause here to see if there are any questions that I'd like to take. Thank you so much.